Hello everyone, my name is Josh Bond and I wanted to introduce you to my project for this semester. My project was to create or recreate an older style puzzle game, a two-dimensional video game that was originally created by Sega, and they called it Columns. Now, Sega at the time was competing with Nintendo for the home video game market, the console game market. And this maybe was 30 years ago, and Nintendo had Tetris, and Sega produced Columns as the answer to the very, very popular Tetris. And Tetris is still around today, and in fact, in academic circles, I think anybody who has ever made a program for a computer science style class, it seems that half of the people out there pick Tetris, and everyone and everybody has made Tetris at some point if you look on GitHub and different places. I wanted to do something just a little different, but I like the Tetris style play. But Columns, it rhymes with Tetris, but it's different. It's not quite the same game. There's a different strategy, but it was certainly, there's no doubt that it was certainly inspired by Columns. And here you can, by Tetris. Columns was inspired by Tetris. You can see here that rather than the Tetris style pieces, you have just columns, which is I think what the game was named after. There are 3 colors per piece, and the idea is to match them horizontally, vertically, or diagonally, right? Or this way, diagonally as well. So if we had one more red piece here, we would have a match. And it's 3 or more matches. So if you have 2 matches here, say you have 2 red pieces here, and then an empty spot, then 2 more matches here, and then a red piece occupied this spot, all 5 of these spots would then have red pieces, and they all should match and blink once, blink a few times and then disappear. And that's what you'll see in the game is, let me just skip ahead a little bit because I want you to see how one piece, when it's placed, can cause a match to be found in several other areas like that. And it makes sense if you think about it. When a match happens, those pieces disappear, whether it's 3 pieces, 4 pieces, or 5 pieces, whatever. They disappear from the board. Any pieces above them then fall toward the bottom of the board. That creates a new board alignment, and you have to check that. So every time, your game logic has to be, every time a match is found, do another check. Because every time a match is found, a new board alignment does happen, and there could be more matches. So I think this gives you a good overview of the game, how it works. My version of the game, which is what you really want to see, right? My version of the game, well, it's pretty similar. Now, I didn't create these graphics. I got them off the internet, and I sourced them in my report. And I did make the header graphic, but again, that's really just a combination of the images I got off the internet, right? The background in a different direction, and the jewel pieces. I called it jewel match. Yeah, a little bit unoriginal there, but we hit the start button and pieces fall just like in the real game. Like in the real game also, you can make the pieces fall faster like this. And let's see if we can't get just a simple match so you can see the animation. And they disappear. Now you wouldn't think that animation is that important for the game, but it really is, because without the animation, you just have pieces suddenly disappearing. And it can be disorienting for the user as to why something just disappeared when they weren't expecting it to. And you think, well, what? Well, yeah, sometimes you have obvious matches on the board, and then sometimes you don't, and it's possible. Let me see if I can get it. There we go. I placed one piece, and you had 2 different matches that came up. And if you have a lot of that going on a more complex board, it can be disorienting for the player to just have blocks disappearing. So that's something that I put a fair amount of effort, maybe more than I should have, a fair amount of effort to getting that to work in this game. And to be honest with you, I never really was 100% satisfied with my code there. I achieved the animation through a timer. Now I was certain that threads were the way to go here, that I could get the desired effect through a thread, or a swing worker is a specific type of thread for swing games. This is not a Java FX GUI. This is a swing, and I never could get. I could get the pieces to disappear. They just flat would not animate properly. They wouldn't flash on and flash off. I worked hard on that, and I just couldn't get it to work through threads. And like I said, I know that's probably the right way to do it. Timer, It's not, for a variety of reasons, dealing with the game flow, it may not be the best idea. But at least, I mean, it works. You can see it works here. It just had this nagging feeling. You had this nagging feeling sometimes that something's not quite right. And I always had this feeling, especially when we went over threads, that threads is the way I should go, but it just wouldn't work. I think Java FX, it would have been easier to get it to work with Java FX. But the timer works okay. It's just maybe not the best. The best solution. So you saw the pause indicator here, and you can hit the button, or you can do it with the space bar. And the game is over when the pieces on the board extend too high and they go off the board like that. Now in this case, we have a score of 52, and you see the high scores pop up here. We have a score of 52, and if we type in a name, let's see, John, then we click OK. Now we see John, high score 52. Oh, that works good. One of the biggest challenges in the game, well, it took me longer than it should have to realize that it could be very simple, and I was making it too hard. This is the heart and soul of the game here. This is a two-dimensional array. And this is true in every game, I believe. You have a data structure, or many times more than one data structure, holding data in the game. And you have to represent on the screen what's happening in the behind-the-scenes data structure. In this case, this is a two-dimensional array. And the challenge here was to check these cells for matches horizontally, vertically, and diagonally without going out of bounds. And you can hard code it. I mean, that certainly is a valid option. It's only 13 rows tall and 6 rows wide, so you can definitely hard code it. But I wanted to do an algorithmic approach, and my first attempt at it worked, but it was bad. It was so bad that the next day I couldn't even read my own code and understand why it did what it did, because it was bad. Let me tell you, it's like 175 lines of total badness. So then I decided to put pen to paper and realize, this is just a graph like you learned in middle school, high school, X, Y coordinates, right? So, if 0, 0 is up here, and it always is on a two-dimensional array like this, if 0, 0 is here, then really all we need to directly check are these cells through here, right? So if this is the x-axis, if x is 0 here, it's 1 here. So if we start our check here, if we check for x here, then the next check would be x minus 1 and x plus 1. And the beauty of this solution is it won't take you out of bounds as long as you only directly check this portion of the columns here, right? So if this is x, then you would check x plus 1, and this would be x minus 1. But you would never put x here and say, let's check here and do x plus 1 here, because then you're out of bounds. And the same over here, if this is x minus 1 is out of bounds. If we're looking at the y-axis, right, this would be y is 0 here, so y is 1 here. We check y minus 1, then we check y plus 1. Then we would check, then on the next iteration of this would be y here, this would be y minus 1, this would be y plus 1. We always check in iterations of 3 going across until we've exhausted the board. Now, I'm not saying this algorithm is going to win any Big O notation awards. I know better than that. I've never had an algorithms class, and that maybe shows a little bit. The code, though, is very readable. It's only about 50 lines, and it systematically checks horizontally, vertically, and diagonally in the way that the iterative way I just showed you. And there could be a better way to go about that, but this works pretty well, and certainly this overhead's not that big a deal. But here, I'll show you the code for that real quick. Because if you remember the Cartesian coordinates that you learned back in school, the x, y axis, I mean, that's all this is. It's doing exactly what I just said with x and y, and then x plus 1, and then x minus 1. That's all it's doing. And like I said, I know it won't win any Big O notation, but it works well. And here, back to the game real quick. The other thing that has to be accounted for is when you have multiple matches on the same board, or let's back up. When you have a match, you find those matches, it flashes, and they disappear, right? I've showed you that. And then it's possible that you can place one piece, that matches, then a new board alignment happens when those pieces disappear, then another match is found. And that can keep going several times. So you can't just remove the pieces from the board on the array. You can't just remove the pieces from the back end two-dimensional array. Because if you do, if we remove all the pieces that matched on the first check, then what if on the new board alignment, the piece that we just removed was key to another match in another direction? Well, so what the code does, and this took me a while to realize as well to get this to work, is I put it into a set. I chose a set because I only care about one instance of each cell. And then we put each match into a set, and then once we're done with all the checks, right? Once we've checked the board and there is no matches, because as long as there is a match, we're going to recheck the board. Once we get to that point, then I go through the set and remove the cells from the two-dimensional array. And I chose a set because, like I said, I only care about, cells 0, 0, or I only care about the coordinates once, and if it won't put it in more than once, that's fine. It only needs to, we can only remove it once. So the game overall, and don't worry, I'm not going to go line by line through the code or anything crazy, because that would be way too boring for you, and you'd probably spot way too many things I could have done better. But you see here the game. This is the game loop. This is called game. A better name maybe game state for the class, but this kind of manages the overall game at a very high level. And the way I try to set up the classes is I try to set it up just like you see it. I mean, of course, you can't see the game class in the game, but it doesn't have a physical representation, but it's there because it controls the game. But you can certainly see the game frame class. That's the main J frame. That's the main window. And the J frame, the game frame class right here, it has as its components the top header panel, the game background panel, the block preview panel, which shows you the next piece. And the way I thought about it and the way I structured it is, the J frame, the game frame, I mean, it has as its component the grid panel, right? The grid panel handles the panel logic, the J panel paint components for the game. And then the grid panel, it has as its component the grid. It has a relationship because in the grid panel it has a grid, and the grid has a block. So it made sense for me to set up the classes like you see here. And then of course there's a sound class, and we have a few like the utility class. It handles disk operations for the high scores. The high scores, there's a lot of ways that I could have done this, but the way I chose, I tried to reinforce something that we learned in class with object serialization. Rather than just creating a text file and putting them line by line in there, I created a high score object. You might also call it a player object if you wanted to. That would be correct. It has the player name and the score, and then I write an array list of those objects. I don't write the objects individually. I write them as an array list to the file. That's easier to manage and easier to control and easier to sort in the high scores list. It was for me, and I think in this class we focused on comparable, but I used compare to because I had to override that to get the sorting to work right in the array list, because when we pull it from disk, we have to, or before we write it to disk, ideally we sort it, and then I also sort it when I pull it back off the disk as well, just to make sure that, because you want the high scores list to be descending with the top scores on top. And I think this gives you an overview, a good overview of the game without, like I said, without going line by line and getting too crazy with that. But this gives you an idea, for better or for worse, how I structured it. Certainly, I think in some classes they got a little big, like grid. I think perhaps I should have broken up grid into some smaller classes. I definitely think I should have done that. And I also had this sort of haunting feeling that maybe there was a better configuration for these class relationships. I don't know what it could have been. Maybe a software design class will clarify some of that. But this is by far the biggest program that I've ever written, and I think it turned out pretty well in the sense that I had something to turn in on time, and that's always good, right? But yeah, if you've never heard of this game, you can look it up and play it online. To say the original Sega, you don't need an actual Sega. You can play it in your browser. It'll run in your browser. You can Google it, and you can see that. And it's worth playing for a few minutes, especially if you like Tetris and you want a different feel for a Tetris style game. And I really enjoyed making it. It was a lot more work than I thought it would be. I guess the biggest lesson I learned on this game, the biggest development lesson, is don't make don't make a game, any kind of game, even a simple two-dimensional game, unless you have time to set up unit testing. That was a problem, because you wouldn't believe there's so many moving parts. Of course, you see that on the screen, but behind the scenes, there's a lot of moving parts, a lot of logic, and it's very easy to make a change in one spot that breaks things later. Now, you won't find it immediately, of course not. You'll find it a day later or hours later, and you won't know why that feature was broken, how it got broken, and what caused it. And I spent a lot of time backtracking, chasing down bugs that were added or created when I added a feature or when I fixed another bug. With unit testing, you can set up your tests, 75 or 100 tests for a small game like this. You could make your changes, and after each change, you could run those tests, and a few seconds later, you'd have a good understanding. You would know for sure whether what you just did broke something or not. That's my biggest regret. But at the time, I didn't set up unit testing because I just didn't think I had time, and it was going to slow me down, and I was worried enough about just getting this done. I could always hear the clock ticking on this project, and because you have 3 weeks, but the reality is we don't quite have 3 weeks, because we have labs and assignments that eat up quite a bit of time, and keeping up with the book reading. I mean, this is a lot to cram into 6 or 7 weeks, and but like I said, I enjoyed making it, and I hope I've maybe shown you something you didn't know about the older style games, and I hope you guys enjoyed the video. Thank you.